Good evening, sir.
Yes, good evening, everybody. Can you hear me?
Yes, sir.
So, in the last lecture, what we have seen, we have seen the different De Morgan's theorems, okay, and we have seen the SOP and the POS, okay, and we have seen the conversion of the gray code into the binary and binary to the gray. Also, we have seen the min terms and the max terms, and we have seen the different types of logic gates, basic gates, universal gates, and the combinational gates. And we have seen some part of the K-map, okay. K-map we have seen, yes or no? K-map we have seen or not? So we'll see now, today we'll see the K-map also, okay? We'll see, we'll continue with the K-map.
Can you speak a bit louder?
Okay, okay. So we have to see the minimization technique using the K-map, okay? We have to see up to the 4 variables with the don't care conditions. So here we are going to see the 2 variable, 3 variable, and the 4 variable K-map. So in the what is the K-map? So this K-map is a method of simplifying the Boolean algebraic expression. Okay, so it was developed by the scientist Carnot in 1953. Okay, so this is used to simplify any Boolean algebraic expression is given to you, and if you want to simplify it, so you can use this method of the K-map. Okay, so in the 2 variable K-map, here you can see this is the 2 variable K-map. So we are having the 2 values, 2 variables, that is A and B. Okay, so for the 2 variable K-map, for the 2 variable K-map, we are having the two variables, that is A and B are the two variables. So the number of cells will be how much? Number of cells for the two variable K map will be how much? Number of cells will be what? 2 raised to n, where n is the number of variables. The number of cells for the two variable K map is 2 raised to 2 is equal to 4 cells. Okay. 4 cells we are having for the two variable K map, and for the three variable K map, for the three variable K map, what is happening? The number of cells is equal to how much?
8 cells.
Number of cells is equal to 8. Number of cells is equal to 8. And for the four variable K map, for the four variable K map, the number of cells is equal to 16. Okay. 16 cells. So this A and B are the inputs, okay, or the variables. So for the two variable K map, we are having the two variables A and B. So the value of A can be either 0 or 1, and the value of B can be either 0 or 1. Okay, so one variable can have two combinations, means either it can be 0 or it can be 1. Okay. So when A is 0 and B is 0, the value of that cell is 0. When A is 1 and B is 0, the value of that cell is 2. When A is 0 and B is 1, the value of that cell is 1. When A is 1 and B is 1, the value of that cell is 3. Okay. So this 0, 1, 2, 3 is the value of that cell. Okay. And for the two variable K map, for the three variable K map, we are having the three variables A, B, and C. So AB can have the value from 0, 0, 0, 1, 1, 1, and 1, 0. And the C can have the value either 0 or 1. For this three variable K map, here we are having the first cell is having 0, 0, 0. So the value of this is 0. Next cell 0, 0, 1. So value of this is 1. So this cell we are having 0, AB is 0, 1 and C is 0. So value is 2. Here we are having AB is 0, 1 and C is 1. So the value of this is 3. Here AB is 1, 0 and C is 0. So the value here is 4. Here AB is 1, 0 and C is 1. So the value of this is 5. Here AB value is 1, 1 and the value of C is 0. So here we are having 6. If AB is 1, 1 and value of C is 1, so here we are having 7. Okay, so depending upon the binary values, we can name the cells 0, 1, 2, 3, 4, 5, 6, 7. Okay. And for the four variable AB and CD, we are having the 16 cells, and the value of that cell can be from 0 to 16. Okay.
Yes, sir.
So next, what we have to do? So next here we are having one truth table. Okay. So in this truth table, we can see that the value of the inputs A, B, and C is given. So here we are having the three variables A, B, and C, and the output of this truth table is Y. Okay. So for the three variables A, B, and C, we are having the corresponding output Y. So for how to represent the truth table in the form of the K map. Okay. So we'll represent the truth table on the K map. So how we have to do this? So we have to represent the truth table in the K map. So for the three variables, we'll have the three variable K map. Okay, so here we'll draw the three variable K map for this truth table We'll draw three variable K map. So here we'll have the value AB. Okay. And here we'll have the values. So the AB here will be 0, 0, 0, 1, 1, 1 and 1, 0. And the value of C can be either 0 or 1. Okay. So we have to enter the values now. So for 0, 0, 0, the output is what? 0. For 0, 0, 0, we'll enter here 0. For 0, 0, 1, the output is 1. For 0, 0, 1, the output is 1. Okay. For 0, 1, 0, the output is again 0, 1, 0, the output is again 1. For 0, 1, 1, the output is 0. For 1, 0, 0, output is 1. For 1, 0, 1, the output is 0. For 1, 1, 0, the output is 0. And for 1, 1, 1, the output is 1. So in this way, we can represent the truth table in the form of the K-map. Okay. So understood how to enter the values from truth table to the K-map.
Sir, please repeat.
Okay. So in this truth table, you can see that in this truth table, you can see this truth table. A, B, C are the inputs and output is Y. So we are drawing this K-map for the three variables. So input variables are A, B, and C, and output is Y. So this truth table is for the Y, that is the output. Y is the output. So we are drawing this truth table for the output. For the corresponding input, what is the output? We are writing in the truth table. So for the inputs A, B, and C, means for the input 0, 0, 0, the output is 0. Okay. So for the input 0, 0, 0, we have written here 0. For 0, 0, 1, 0, 0, 1, the output is 1. So we are writing here 1. For 0, 1, 0, 0, 1, 0, the output is again 1. For 0, 1, 1, for 0, 1, 1, the output is 0. Okay. For 1, 0, 0 means A, B, and C. AB is 1, 0 and C is 0. AB is 1, 0 and C is 0. The output is 1. 1, 0, 1 means AB is 1, 0 and C is 1. The output is 0. AB is 1, 0 and C is 1. The output is 0. Okay. Now AB is 1, 1 and C is 0. AB is 1, 1 and C is 0. The output is 0. AB is 1, 1 and C is 1. AB is 1, 1 and C is 1. The output here we are writing 1. Okay, understood now how to write down
Yes, sir.
representation of truth table on the K-map. Okay. Now I will give you one expression and you have to solve it by using the K-map. Okay. Suppose the expression is y is equal to a bar, b bar, c bar plus a bar, b c plus ABC plus A B bar C bar. Okay. So this is the equation. How to represent this equation in the form of the K-map? Okay. How to write down this equation in the form of the K-map? Do you know that? How we'll represent this? This equation is in the sum of product form, SOP. Okay. This equation is for the SOP. That is sum of product. So these are the product terms. That is A bar, B bar, C bar is one product term. A bar, B, C is one product term. And ABC is one product term. And A, B bar, C bar is one product term. So when we'll add these product terms, then it forms the sum of products. Okay, SOP equation. So now how to express this SOP equation in the form of the K-map? So for these three variables, we have to draw the three variable K-map. Okay. For these three variables, we have to draw the three variable K-map. Are you all there?
Yes, sir.
Okay. So here we can write down here AB. And here we can write down the variable C. Okay. We will draw the K-map for the three variables A, B, and C. So the C can have the values 0 or 1, and AB is having the values. What are the values for AB?
0, 0, 0, 1.
Here we are having 0, 0. Then we are having 0, 1.
0, 1, 1.
1, 1 and 1, 0. Okay. So each cell is differing by 1 bit. Okay. So 0, 0 and 0, 1. So this differs by 1 bit. 0, 1 and 1, 0. So this bit differs by 1. And 1, 1 and 1, 0. So this bit differs by 1 bit. Okay. So we are each cell is differing by 1 bit. So now for this A bar, B, C bar, the binary value will be what? 0, 0, 0. Okay. For A bar, B, C, this will be 0, 1, 1. For A, B, C, it will be 1, 1, 1. And for A, B bar, C bar, it will be 1, 0, 0. Okay. So this will be the different values. Now we have to, for this specific value, we have to enter the value 1 in the truth table. Okay. For 0, 0, 0, we'll write here 1. Okay. For 0, 1, 1, 0, 1, 1, here we'll write 1. For 1, 1, 1, here we'll write 1. And for 1, 0, 0, 1, 0, 0, here we'll write 1. Okay. So you understood how to write the equation in the form of the K-map.
Excuse me, sir.
Yes.
Sir, and what about the blank box? We have to leave it as it is?
You can enter the zeros there, or you can leave it as it is. Okay.
Yes, sir. Thank you.
Sir, how 0, 0, 0 is 1?
What?
First, how it is 1? First, chord box. It will be 0.
I'm not able to hear you.
Sir, how the 0, 0, 0 is 1?
Because it is the SOP equation, sum of products. So for sum of products, the equation y is equal to 1. Means for this means for this product terms, we have to write down the 1. Understood or not? So for the SOP, that is sum of products, for this product terms, the value is 1. Means if you will take this 0, 0, 0, this is 0, 0, 0 means 0 bar, 0 bar and 0 bar. So 0 bar will be 1.1.1. So this will become 1. If you take here 0 bar, that is 1.1.1. So this will become 1. This is already 1, 1, 1. So 1 into 1 into 1. The product terms, we have to write down 1. Okay. So for this 0, 0, 0, here we are writing 1. For 0, 1, 1, here we are writing 1. So depending upon the product terms, we have to write down the ones. Understood or not?
Yes, sir.
Yes, sir.
So after this, now we have to group the number of ones. Okay. So what is the process for that? How we have to group the ones? So group may not contain 0, so it will not contain 0. So we can make the group of only 1, or we can make the group of 2 ones, that is known as the double. If the group of 4 ones, it is known as the quad, and if the group of 8 ones, it is known as the octet. Okay. So we have to group, each group should be as large as possible, and the cells that are containing 1 must be grouped. Okay, the cells which are having 1 that are grouped. So groups may overlap. Okay, we can overlap the groups, and opposite grouping and corner grouping is also allowed. So opposite grouping and corner grouping is allowed. So here we'll start the grouping. So we can make the group of these 2 ones. Okay, so we can make the group of these 2 ones, and this one and this one can be grouped. So this is known as the opposite grouping. Okay, this is known as the opposite grouping. This is known as the opposite grouping. This is one group and this is one group. So for this group, we have to write down the expression. Okay. So by grouping these 2 ones, what is happening? For these 2 ones, the value of C is 1, and the value of A is changing from 0 to 1, and the value of B is 1, 1. Okay. So here we can write down, for this group, we can write down the value as BC, because the value of C is 1 and the value of B is also 1. Okay. So we can write down the, for these 2 ones, we can write down the expression is BC, and for this opposite grouping, the value of C is 0 and the value of A is changing from 0 to 1, but the value of B is 0 here, and here also the value of B is 0. Okay. So we can take it as B is 0 means we can write it as B bar, and C is 0 means it is written as C bar. So we can write down the final expression of, for this minimized expression is what? BC plus B bar C bar. So we have simplified the expression, that is A bar B bar C bar plus ABC plus A bar BC plus ABC plus A B bar C bar. Okay. So we have minimized the expression. by using the K-map. Understood this? Yes or no?
So can you repeat it once again?
Okay, I will repeat it again. So first, what is happening? The expression is given that y is equal to a bar, b bar, c bar plus a bar, b, c plus a, b, c plus a, b bar, c bar. Okay. So this is the SOP equation, that is sum of products. So this a bar, b bar, c bar is one product term, a bar, b, c is one product term, and a, b, c is one product term, and a, b bar, c bar is one product term. Okay. So when we
Explain
are
that opposite grouping again.
grouping, okay. You know how to write down the from the equation, how to write down the truth table, that you have understood, na?
So
Okay, so grouping I will show you. So first we have to identify the adjacent ones, then see the values of the variable associated with these cells. So the only one variable which will be different and it will get eliminated, and the other variables will appear in the ANDed form. Okay.
okay, sir.
So we have to determine the term corresponding to each group of the adjacent ones, and these terms are then ORed to get the simplified SOP. So here we got BC and B bar C bar as the two terms. Okay.
Okay, sir.
Should I erase this? So now I will give you one expression. Now you tell me the answer for that. What is the minimized Boolean expression? Okay. So I am giving the expression A bar, B bar, C bar plus A bar, B, C bar plus A bar, B, C plus A, B, C bar. Okay, so this is the expression in the SOP form. Now tell me simplify this expression and tell me the answer for this by using the K-map. To simplify this expression by using the K-map and tell me the minimized SOP. Are you solving this expression? Yes or no?
Sir, doing sir.
Yes, sir.
So for this, you can draw the K-map like this. There are three variables A, B, and C. So for this AB is the two variables, and the C is another variable. Okay. So for this three variable K-map, we have the 8 cells. So the value of C can be either 0 or 1, and the value of AB is 0, 0, 0, 1, 1, 1, and 1, 0. Okay. So this is what A bar, B bar, C bar, 0, 0, 0. This is 0, 1, 0, and this is 0, 1, 1, and this is 1, 1, 0. So for this values of the binary, we have to write down the 1. For 0, 0, 0, we are writing here 1. For 0, 1, 0, here we got 1. For 0, 1, 1, 0, 1, 1. So here we write 1. And 1, 1, 0. Here we
One.
write the 1. Now how to group these ones? How will group the ones? So we can make the group of these two ones, okay? These two adjacent ones. Then we can make the group of these two ones.
And the left one.
Then this. So this is known as the overlapping. Okay. We can overlap these two ones and these two ones. Okay. So we are making three groups. So for this group of two ones, what will be the expression for this? What will be the expression for this? And what will be the expression for this? For these two ones, what will be the expression?
Sir,
So for these two ones, the expression will be what? A bar B. Because for these two ones, the value of A is 0 and the value of B is 1. So for 0, we can write A bar, and for 1, we can write down B. For these two ones, the value of C is 0 and the value of A is changing from 0 to 1, but the value of B is 1. For these two group of these two ones, we can write down B and C bar, because the value of B is 1 and C is 0. And for the group of these two ones, the value of C is 0 and the value of B is changing from 0 to 1, but the value of A is 0. Okay. So we can write down it as A bar and C. Can written as It can be written as A bar, C bar, okay? What will be the final expression will be? Final expression will what? A bar into B plus A bar into B plus B into C bar. Okay. A bar into B plus B into C bar plus A bar C bar. Okay. Got the answer?
Yes, sir.
Yes, sir.
Okay. Now we'll see the next, that is the SO. Half adder and the full adder. Okay. The next topic is the adders. Okay. So here we are having the two adders. So the basic adders here are the half adder and the full adder. What is the adder circuit? The adder is used to add the two binary digits. Okay. What is the half adder? So a half adder adds the two binary bits and produces a sum and a carry output. Okay. And these adders are the important in the computers and also in other types of digital system in which the numerical data is to be processed. Okay, so in the half adder, what is happening? 0 plus 0, the output we are getting 0. 0 plus 1, output is 1. 1 plus 0, we are getting 1. And 1 plus 1 is what? We are getting sum is 0 and carry is 1. So these operations are performed by a logic circuit called as the half adder. So this half adder accepts two binary digits on its input and produces the two binary digits on its output. That is a sum bit and a carry bit. Okay. So this half adder logic circuit, you can see here, this is the symbol of the half adder logic symbol. So we are having two inputs A and B, and the output is sum and carry. So the sum and carry are the outputs, and the inputs are A and B. And here we can see the truth table for the half adder. So 0 plus 0, what is the sum? Sum is 0 and carry is 0. When A is 0 and B is 1, so 0 plus 1, sum is 1 and carry is 0. When A is 1 and B is 0, sum is 1 and carry is 0. Okay. When A is 1 and B is 1, both the inputs are 1, sum is 0 and carry is 1. This is the truth table for the half adder. And here we can see that this is the logic symbol. So in this symbol, we can see we are having two inputs A and B. These are the inputs of the adder, and the outputs are sum and the carry. And here we have drawn the logic diagram. So how we have drawn the logic diagram for this half adder? So this you can see, this is the input A and B. And for this input, the sum, output of the sum is what? 0, 1, 1, 0. So this truth table is equivalent to which type of gate? So XOR gate. Okay. This is equivalent to the XOR gate. Yes or no?
Yes, sir.
Because for the XOR gate, when both the A and B are 0, the output is 0. For 0, 1, it is 1. For 1, 0, also 1. And for 1, 1, it is 0. XOR gate, From where the noise is coming? So when both the inputs are 0, 0, some output is 0, 0, 1, it is 1, 1, 0, 0. So this truth table is equivalent to the XOR gate. And for the Cout, for 0, 0, the output is 0. For 0, 1, it is 0, 1, 0, 0. And for 1, 1, it is 1. Okay. So this for Cout is equivalent to which gate? The output of the Cout is equivalent to which gate? This is equivalent to which gate? The output of Cout is equivalent to which gate? Equivalent to the AND gate, na? It is equivalent to the AND gate. Okay. So in the half adder logic diagram, we can see that the inputs are A and B, and for the sum, the output is what? A XOR B. And for the carry, it is equal to what? A and B. Okay. So sum is equal to what? A XOR B. That is equal to A dot B bar plus A bar dot B. Okay. And for carry, it is equal to A dot B. So any doubt in this half adder? Okay, so next we'll see what is the full adder. Okay. So the second category of adder is the full adder. So the full adder accepts two input bits and an input carry and generates some output and a output carry. Okay. The basic difference between full adder and half adder is that the full adder accepts an input carry. Okay. So you can see the logic symbol for the full adder and the truth table shows the operation. So here we are having the three inputs A, B, and C in, and we are having the two outputs, that is Cout and the sum. Okay. So for A, B, and C in, for 0, 0, 0, what is happening? Input is A, B, and C in. So for 0, 0, 0, the sum is 0 and carry is 0. Okay. Then for 0, 0, 1, when A is 0, B is 0, and C in is 1. So here we are having three inputs. So how many combinations will have 2 raised to 3? That is 8. That is from 0, 0, 0, 0 to 1, 1, 1, 1. Okay. So for 0, 0, 1, the sum is 0, sum is 1 and carry is 0. Okay. Next input is 0, 1, 0. So for 0, 1, 0, sum is 1 and carry is 0. Okay. Next input is 0, 1, 1. So for 0, 1, 1, what is sum and what is carry? A is 0, B is 1, and C in is 1. So 0 plus 1, what we get? 0 plus 1 is 1.
One.
And again 1 plus 1. 1 plus 1, we get sum is 0 and carry is 1. Okay. Next input is 1, 0, 0. So 1 plus 0, we are getting 1. Again 1 plus 0, sum is 1 and carry is 0. Next input is 1, 0, 1. So 1 plus 0, sum is 1. Again 1 plus 1, sum is 0 and carry is 1. Okay. Next input is 1, 1, 0. So 1 plus 1, sum is 0 and carry is 1. Okay. Again 0 plus 0, sum is 0 and carry is 1. The last input is 1, 1, 1. What is happening for this 1, 1, 1?
So 1 plus 1 is 1, and again 1 plus 1 is 1.
First we are having 1 plus 1. What is that? Sum is 0 and carry is 1. If we add again 1 here, 0 plus 1, what will happen? 1. And this carry here. So carry is 1 and sum is also 1. Okay. Understood?
Yes, sir.
Here we can see this is the logic symbol for the full adder. We are having two inputs A and B, and the third input is the input carry, and the output we are getting sum and the output carry. Okay. The inputs are A, B, and C in, and the output is what? Sum and carry output. This is the logic symbol for the full adder, and here we are having the complete logic circuit for the full adder. So from this logic circuit, we can see that inputs are A and B. Okay. So the first half adder, and output of this first half adder is given as input to the next half adder. So the input to the next half adder is what? A XOR B and C in. So the output of this full adder will be what? A XOR B XOR C in. And for the carry, the output of the carry of first half adder is A dot B, and output carry for second half adder will be A XOR B into C in. And when we'll make the OR of these two, that the final carry will be AB plus A XOR B dot C in. Okay. This is the complete logic circuit for the full adder. So any doubt in this logic circuit for the full adder?
Sir.
So for the sum, the output is A XOR B XOR C in, and for C out we are having AB plus A XOR B dot C in. So here we can see that how these two half adders are connected to form a full adder. So first half adder is having inputs A and B, and the output is A XOR B, and C out is A dot B. And for the second half adder, the input of the output of the first half adder is given as input to the second half adder, and one input is C in. So the sum output will be what? A XOR B XOR C in, and the carry output will be AB plus A XOR B dot C in is the final carry for the full adder. So in this way, we can use these two half adders to form a full adder. Okay. So any doubt in this? Any doubt in the full adder?
Sir.
Yeah, who is absent for this class?
So one guy is having medical holiday. His hand is fractured. Others are present.
Who is the number is what?
Indra and Sinha.
IME number is what? What is the ID number?
Which I'm checking. 077.
Okay. 077 is absent. Okay. Rest all are present, na?
Yes, sir. So 077 is on medical leave.
Means. Okay, then that's all for today. Thank you. Okay, we'll meet in the next lecture.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Yes.
धन्यवाद सर.
you.